So this is 2.1 day 2. Okay, and I want you to turn to your neighbor and talk about this one. What are some things about this one that we would need to do? And what's going on with this one? Talk about it. Okay, so what would our first step be? Always step 1. What is it?
Factor out the numerator.
Okay. So what does the numerator factor into?
X plus 4 and x plus 1.
X minus 4, x plus 1. Okay. Are there any holes in this graph? No. Okay. So what are some things that we see that are going on here? What are some points we know? Yeah.
It's like a higher degree in the top and the bottom.
Okay. Yes. So this is top heavy, since the degree is higher on top. What does that mean about this graph? Turn to your neighbor. What does it mean when a graph is top heavy? What do we need to do? You can look back to your notes from last class. All right, so what does top heavy tell us about the graph?
No horizontal asymptote.
There's no horizontal asymptote. What kind of asymptote is there? Slant asymptote, yes. How do we find the slant asymptote?
Synthetic division.
Synthetic division, yeah. We have to divide the top by the bottom. So we set it up 1, -3, -4. And we're dividing by x minus 1, so I'm going to put a 1 right there. Bring down the 1, multiply, add. And do I have to do the whole synthetic division?
No.
No. What can I ignore? Yeah. Okay, so I just don't even have to do the last step right there. So what is my slant asymptote? Turn to your neighbor. What is the slant asymptote if I get that as a result? Okay, so I heard you guys say x minus 2. So y equals mx plus b, y-intercept of 2, -2, sorry, slope of 1. So it's like we just graph that line. We just do it as a dotted line here. So it means our curve is going to kind of go towards that instead of the horizontal asymptote, because we don't have a horizontal asymptote. And these little red points here, these are not actual points of the curve. That was just me graphing the line here, so making it try and look accurate. That line is not a part of the graph either. It's just the asymptote. Okay, so what else do we see in our equation? What other points or significant features could I graph?
Asymptote positive 1.
Yes. Okay. So we've got this sort of squished X shape. When the asymptotes look like this, the graph is either going to live here, like across from each other, or it's going to live in the other two regions that are across from each other. And it really just depends on the graph. So it could be one of those two possibilities. It's never going to be like this. Why not?
Because we're gonna cross each other.
What's that?
Because we're gonna cross each other.
They're not going to cross each other? You know what you're saying?
This is not a function.
This is not a function. Yeah, this fails the vertical line test. So they can't be over top of each other like that. You might see sometimes, I don't know. It's been a long time since I've seen one that looked like that next to each other. It's pretty unlikely though, I think. I haven't seen one in a while. Anyways. Okay, so we have some more points that we can plot. X-intercepts, what are they?
Positive 4, negative 1.
1, 2, 3, 4. Okay, that's giving me a hint of where this is. This is over in that right region. And negative 1. Okay. So I can get a pretty good idea of what that graph is going to look like. What is the y-intercept? I would recommend you use this version, the unsimplified version. Shelby? 4. 4 is correct. Okay. So on that side we can see it's going to look like this. So notice just kind of how it's a pretty like shallow curve, but it's going towards that vertical asymptote and it's kind of curving down towards that slant asymptote there. That's basically what the other part is going to look like. If we wanted to just make sure, we could plug in like 2 for x if we want. Not 2. Yeah, actually 2 would work. 2 would be fine. So we plug in 2, we get 2 squared minus 6 minus 4. So that's negative 6 over 1. So that's just like down here. So yeah, that's where our graph is. So big difference here is our slant asymptote. We have to calculate it using synthetic division, and when we graph it, it's going to be a line, like y equals mx plus b, instead of y equals just a number. Okay, let's have you guys give one a try here. Go ahead and graph that one. Seen as I glanced around just now, I saw even more. When we do the synthetic division to do the slant asymptote, because it is top heavy, so we have a slant asymptote. What number should go across the top?
1, 0, and negative 1.
Yes. So we need a 0 because there's no x term in the top right there. Okay, keep going, and then we'll check in a few minutes. Okay, so here's what I'm seeing for the slant asymptote. It's y equals x minus 4. Did you guys get that? Okay, so here's negative 4, slope of 1. It's going to go like that. May need to zoom out slightly to fit this graph on there. Where's our vertical asymptote? -4. Okay, so this graph's, ooh, that's not straight at all. Yikes. Here, let's try this. There we go. There's my asymptotes. Nice. Okay. And then you guys got, for x-intercepts, what we get?
1 and -1.
1 and -1, yeah. So when we factor that top there, it is difference of squares. 1. Any hole in this graph? No. Y-intercept?
-1.
-1/4. So we plug in 0 for x, it's like you can almost scribble those out and see what's left over with the constants. So -1/4. So it's right there. So this isn't giving us like a ton of data, but remember the graph is going to go towards those asymptotes. So what it's going to do is going to go like this. Come through here almost parabola shaped, except it's like more wide as it approaches those asymptotes. And yeah, there is a lot of space in there, and that can happen sometimes. So if the graph is up in that corner, it's likely it's going to be down here in this region, opposite from it. The way that we know for sure is plug in an extra point. What can we plug in for x?
-5.
Yeah. So we want to be on the other side of the vertical asymptote. When we plug in -5, what do we get? What'd you guys get when we plugged in -5? Yeah. -24. Okay, yeah. So that is, I mean, it's down really far. It's like down here. Probably even further, actually. So this one's a little crazy looking, but it's going to have the same shape, and it's going to be way the heck down there. When you're doing these, like on your homework on Delta Math, if you want to check your answer by graphing it on Desmos, feel free to do that. Obviously, you don't get to use Desmos on the test, but if you're just like, really, is that what it looks like? Just put it in there and see. You could also, it's always fun too to just like mess around with numbers on Desmos and see the craziest kind of function of these that you can come up with. So just a free bonus problem out there. Come up with the craziest graph before test day, and you'll win favor in my eyes. Okay, let's do another one. Oops, not that. And then we'll go over the test. Oh, I forgot to talk about domain and range. Sorry, not yet. Not yet. Okay. Turn to your neighbor. What do you remember about domain and range? What are those things? Actually, we'll just do domain for this one because range is too hard, but you still talk about range. Okay, who thinks they have a good like summary of how to explain what domain is? Mo.
So on the x-axis, it's like the numbers in the graph from the negative side to the positive side.
Positive side. Positive. Okay, nice. Yeah, I like that. Any other ways of explaining domain? Different way of explaining it? We're good with that? We like that? It's good? Makes sense? Okay. A way that I like to explain it is a list of the x values in a function. Because not every x value is used, so it's like we're using all of these. But yeah, we look from the negative side to the positive side. That's exactly right. So just a couple different ways to think about it. Range. What would I change about range? What would I change?
So y instead of x.
Yeah, it's y instead of x. Yeah, so it's on the y-axis, the numbers in the graph from the negative side to the positive side, and it's a list of the y values in a function. Okay, so that's domain and range. We learned that way back in the day. So in this graph right here, as I look from the negative side to the positive side, are there any x values that we don't use? Yes. Which one? Yeah, we don't use -4. We use every single other x value. The graph is approaching this vertical asymptote, especially the higher we go, and it's going all the way. It goes forever to the right. And over here, it goes just about as close as you can get to -4, and it's going forever to the left. So our domain, we are going to always do interval notation in pre-calc. It's just from -infinity to -4, and from -4 to infinity. Range for this one would actually be a little difficult. We actually need calculus to know the range, so we won't do range for this one. It's a little easier when there's not a slant asymptote. Slant asymptote range is more difficult. So this is listing all the x values. All of the numbers from -infinity to -4, and from -4 to infinity. Okay, now we're going to do one more graph, and then we will go over the test. All right, so give this one a try. Take a few minutes on this one, work together. There's some new things happening in here that we didn't graph last class. All right, yeah, so let's check in here, because like I said, there are some different things going on with this graph. Is there a hole in the graph? No. Okay, how does the bottom factor? Okay, so vertical asymptotes, where are they? Yeah. So we have 2. So when we have 2 vertical asymptotes, it does divide our function into 3 parts. There's something happening over here, here, and here. So there's 3 different regions. And unfortunately, the rest of our information doesn't tell us very much. But it does tell us a little bit. So do we have a horizontal asymptote or a slant asymptote here? Horizontal or slant?
Horizontal.
Horizontal, yes. How do you know?
Because it's bottom heavy.
Bottom heavy. Okay, and so that means our horizontal asymptote is? Yes, heavy. Y equals 0. Okay, so it's like that. Ooh, yikes. Try and draw that more straight. Okay. X-intercept. Is there a number that would make the top equal to 0?
0.
0. Okay, well if 0, 0 is our x-intercept, it also means 0, 0 is our y-intercept. If we plug 0 in for x, the whole top equals 0, so it's 0. Okay, so this is why we need a lot of extra points in this graph, because we actually only have 1 on the graph. This is not nearly enough information to tell us what's going on. So we just gotta plug away. So we need to know this middle section could look like this. It could look like this. It could look like this. It looks like that. Or it could look like that. The only way that we know is we have to plug in numbers to the left of 0 and to the right of 0, because we have to know which way it's curving. There's no way to know from this graph right now. Yeah.
Would it still go through even though the 0 is the horizontal asymptote?
Yes, so this is one of those times when a graph can cross a horizontal asymptote. So a horizontal asymptote is mostly telling us about end behavior, and it is rare, but it does happen. So the horizontal asymptote's not telling us what happens in the middle of the graph, it's telling us what happens to the far left and far right. Okay, so if we plug in, let's say, -1 for x. Did anyone plug in -1 for x? What'd you get?
5/8.
Yeah, 5/8. Okay, so that's like there-ish. And then 1 for x, what do we get?
1/2.
1/2. What do we get when we plug in 1? 5 over -8. Okay, so we get -5/8. Okay. So that's telling us we're going to have a sort of x cubed looking shape here in the middle. Okay, is that enough points to give us an idea of what's going on here? No, we've got those other 2 regions. So if I was going to plug in 2 more points, what should they be? Whoa. What should I plug in to let me know what's happening outside there? Cool.
4.
Yeah, what'd you get when you plugged in 4?
20/7.
20/7. Okay, so that's like 2.9-ish. It's almost 2 because 21/7, or it's almost 3, sorry. It's almost 3 because 21/7 would be 3. So that means it's up there. That's telling us it's doing this in that region. And then what's another point we should plug in?
-4.
Yeah. And what do we get for -4? I have a guess. I haven't done it, but I have a guess.
-20/7.
Yep. That was my guess. Okay. So this graph is down there. So if we have more regions to the graph, we just need more points to figure out what's going on. But remember, you can do this for every function in the world. You can plug in numbers for x, and you get points for y, and it tells you where the graph goes. Okay, domain. Are there any x values that this function cannot equal? Luke. 3 and negative 3. So we go negative infinity to 3, parentheses, union, negative 3 to 3, union, 3 to infinity. And that interval notation is basically just following the graph from left to right. It goes from negative infinity to 3. Okay, pick back up. 3 to negative 3 to 3, and then 3 to infinity. And notice that corresponds with where the vertical asymptotes are. If we had a hole in the graph too, we would also want to exclude that point from the domain. For the range, any y values that we can't equal. Yeah, there's none. We actually can equal all of them. So if we look at this section of the graph and that section, we only look at those two, we might think like, oh, we can't equal 0. But we have this middle section here that goes through 0 and goes from negative infinity to infinity. So that's one of the tricky parts of this is we have to look at all regions of the graph.